Good afternoon. My name is Lionel Bran, and I was until yesterday the steering committee chair. The next award talk is about a newly established award that the steering committee decided to create last year, called the Career Award. I won't talk for very long now. I will explain to you tonight during the banquet when I actually hand out the award, why this award was created, how people are selected to receive the award, and why this is important for the models community. But without further ado, I will leave the floor to the speaker. Thank you.
Oh, there's a microphone there. In case you're following the schedule, my name is not Dimitris Kolos. I'm Bran Selic. I'm intimidated by, it feels like I'm being surrounded by triangular-shaped aliens that are about to abduct me, but so it's, I'm a bit nervous. It's a little bit ironic. You see, I'm one of the people who foisted UML on you. And I don't get many nice words as a result of that. But I thought it might be fair at this point to say, okay, the UML is still around. So what went right? Obviously, we know what went wrong, and everybody has a favorite theory. But I'd like to take the opportunity to actually honor a contributor, a very worthy contributor and a friend of mine with whom I worked with and against at different times, Stuart Kent, who unfortunately died a few weeks ago, but he was one of the people that was instrumental to what UML is, to what OCL is. I don't know how many people here knew, I can't tell here, but knew Stuart. He was a wonderful man, and certainly technically, if there's any value in UML, he can take credit for a lot of that. One of the things that he worked on was the so-called precise UML group that tried to influence time and time again to make UML more precise, more structured, and so on. And so he was a contributor to UML and model-based engineering. Unfortunately, he went to the dark side at one point and switched to Microsoft. I went to the other dark side, which is called IBM. But you know, there was a nice, at one point, with all that work that Stuart was doing, there was an attempt to restart and rebase UML, and here's a list of the vision that that Stuart actually had for UML 2 when it happened, which was somewhere in the early 2000s. I've already forgotten the exact dates, but you know, this was the key point. UML should be unambiguous, meaning that you actually knew what it actually, when you drew things or specified things in UML, you knew what it stood for. And you could always add interpretations on top of it. That doesn't prevent you. And that's a key thing, that even though you might have defined a language precisely, you can still use it loosely. And this is key. And then there was a series of things, separation of concerns. In other words, be clear about what is semantics, be clear what is syntax. Integrated modeling language is this idea that you have different aspects, behavior, structure, and so on, and identifying nicely what are the modules that deal with which aspect of things. Should be complete. This one is always problematic. If you believe in Gödel's theorem, it's either complete or consistent, if it's but not both. Should be layered and extensible. This is this whole idea of UML, which started with Steve Cook, that UML should be a family of languages. Okay. Consistent and disciplined architecture, which certainly wasn't the case with what we ended up with, and formally checked in a tool. So that was the vision that Stuart had, and a number of other people that were working with him. That's not what happened. In fact, what happened was something that Pete Rivet, who is still involved with the OMG, and he's one of the people responsible for MOF, called the Byzantine behemoth. So there's plenty of opinion on what's wrong with UML. Most of them, by the way, are wrong. Here's a bunch, representative bunch. It's either too big, it's too broad, it's too fuzzy, too unstructured, too narrow, too precise, and so on and so on. By the way, if you want to know what's wrong with UML, come and talk to me, I can tell you. Notice this, by the way, too big and too narrow. So some people liked the fact that it was, or didn't like the fact that it was too big. A lot of people don't like the fact that it's too big, although in its defense, I have to say we're trying to do complicated things with this, right? You know, you could go take it all the way down to a Turing machine language, which in principle you can do anything with, at least anything that's computable, or you can go in the other direction. But some people actually complained about it being too narrow and they couldn't do things with UML that they wanted to do. Then there's this one that says, oh, it's too precise. Martin Fowler, for example, complained about it being actually too precise because he used it for sketching. And he thought now that we add precision, it becomes a lot more difficult to learn this kind of thing. So anyways, most of these are actually valid complaints, I would say. But as I said, given that it's still being used, something was right about UML. I must say I was surprised because when I actually fought against UML first before I joined it, that was the complaint, was that it was perhaps trying to attack too broad a spectrum and that the future lies in domain-specific languages. I still believe that, but that doesn't necessarily exclude the concept of UML, at least as it should be, not necessarily as it is. So what went right? You know, what were the things that, because I must admit, it surprised me. The way that UML was accepted surprised me. I didn't expect it to be, but in a couple of years, it suddenly became a topic or actually a topic of courses at universities. So something was right there, and one of them is, of course, and I'll talk about this one a little bit more in a second, there was a desperate need in industry for a standard. There was this proliferation that I'll talk about in a second that just made it impossible for anybody who wanted to do some kind of modeling work associated with, say, object-oriented languages. They needed something to consolidate these things. This idea of model-based engineering was pretty raw, and it was all about object-oriented. Modeling was not even mentioned as a particularly interesting or focus, if you like. It was all about object orientation, but it introduced the idea of model-based engineering as perhaps something worthy of deeper examination, and that's why these conferences, in fact, if you might, some of you might recall that these conferences were called UML. I forget, for the first 7 or 8 years they were called UML. For the academics here, I'm sure a lot of them are happy with it as a result because it gave them something that they could attack and improve on. Okay. And it was in many ways the initiator of a lot of this wonderful work. I really like the work that was done in Epsilon, the work that Dimitris talked about, the work that's needed at the foundations to make this a real serious discipline. This is mostly due to Steve Cook because it was rather vague in the minds of the three amigos, so-called amigos. This idea of a language family as a foundation for a family of languages, which I think is absolutely an ingenious idea because it provides a common base which helps us perhaps. One of the problems you have with domain-specific languages is that it's all about decomposing systems and dealing with different aspects of a system with the language that is most appropriate. But as Michael Jackson reminds us, after decomposing a system, we still have to put it back together again. And providing a common base for a set of domain-specific languages strikes me as a very interesting way of possibly getting over the problem of fragmentation that happens when you have domain-specific languages that deal with the same system but in different aspects of the system in using completely different formal foundations. So although I'm not sure, I'm pretty sure this is not the best way to do it, the way that UML has dealt with its profile mechanisms and so on, I'm pretty sure that this is a worthwhile idea, the idea of a base language that is then used, that might have a common semantic foundation out of which we can grow a set of domain-specific languages. I think that is probably the best way to deal with domain-specific languages. Not because of UML so much, but because of this idea that we need to integrate things. So if I have a domain-specific language that talks about a communication channel from the perspective of the people who do accounting and the people who do the actual allocation of bandwidth, for example, in that channel, they're all talking about the same thing. And of course, if those languages are completely distinct, we have a problem. And to be honest, well, to my surprise, it was actually applied with great success in some cases, less success in others, but it has actually been applied in industrial practice successfully, in spite of everything, if you like. So let's just go back a little bit. I can recreate some of that because to a certain extent I've been involved with this almost from the beginning, not quite. And I don't know if Aristotle mentioned this or somebody else quoted this, but I'm a firm believer in this idea that in order to understand anything, and something as complicated as UML, you have to go back and understand how it came about, how it came to be. And it came to be in a weird kind of way. So we had this, in the mid-1990s, the object-oriented paradigm suddenly hit the software community. And people realized that there's something very useful and interesting in this. And associated with it, suddenly there was this influx of published object-oriented methods. There were literally over 80 published, and a lot of them had associated tools with them. One of the interesting things, the reason, by the way, and this is my interpretation, the reason I think there was an interest in and an explosion of modeling and notations has to do with the fact that the object paradigm is inherently structural, because object-oriented programs are typically networks of collaborating objects. I'll get back to that. I think that's a fundamental reason, and suddenly, of course, because you're talking about networks, these things nicely map to graphs, and you could actually describe object-oriented programs using graphs. And of course, if you added also things like state machines, which are very much skewed towards a graphical rendering, you will see this thing coming through. So that doesn't surprise me, but there were all these methods, and of course to people, not just commercial users who wanted to take advantage of this, but also, of course, even to researchers, you had to make a commitment on one end or the other. You committed to a particular tool, and the tool was supported by maybe a small group somewhere or a small company somewhere, and of course you couldn't talk to the other people. So there was definitely this desperate need for some kind of unification, which at the time I didn't agree with, because I had a company with three of my colleagues that was quite successful with a domain-specific language. But amongst these 80 or so object-oriented methods, there were three that were perhaps particularly noticeable. A lot of it had to do with being there in the right place at the right time, and I would say Grady's book, which was very readable, quite entertaining in some parts, was a bestseller. It was very well written. It explained the core concepts nicely. A more, if you like, technical book, but because it was so technical in a sense, provided some kind of more precision to the kind of stuff that Grady was talking about, was the OMT work of Jim Rumba and his colleagues. And that book was also quite a bestseller. I think Jim told me it was around 100,000 copies, which for a technical book is an amazing rate. And then there was the work on use cases and basically requirements modeling that grew out of Ericsson, and that Ivar Jakobsen put in his thesis. That was also an outstanding thing, although the book wasn't as readable as the other two. And then there was this brilliant move by Mike Devlin, who was the CEO of Rational Software, and he said, Grady was already working for Rational, and they had a lot of people who were interested in Grady's work, and he said, what's the next best or most popular OO methodologist? So that was Jim Rumbaugh, and they had him, so they hired him, right? And then in came Ivar, right? Now, at that point, we had the great Rational Rose catastrophe. It is unfortunate because, as I say, it was a real bestseller. I used to know these Rational salespeople, and they just basically took orders over the phone. It was a time of great interest in object orientation, and people believed that tools like Rose was going to really help their productivity and so on. It was really a drawing tool. I have no amount of disdain for this tool. Unfortunately, it has a lasting legacy. Almost every modeling tool since then has emulated the style of Rose. That's a tragedy. And that's one of the reasons we have so many problems with tooling, especially model authoring tools. It really is too bad. But getting back to the business, when these three got together, they published something called UML 0.8, and then they sent this out to a number of people, some of the methodologists and method people that had already published works, and it was another brilliant marketing idea, which was, let's see if we can consolidate and get some of the famous names involved with this. So they invited a number of people. We in my company got invited as well. We thought it was a ruse. Oops, sorry. So we didn't actually respond until later. And then there was the next brilliant idea, which is the OMG was doing things with object-oriented middleware. And this idea was, maybe we can standardize this. Again, a fantastic move on behalf of Rational management, and they invited out, and truly a lot of people did actually contribute to these methods. If you ask me, that's where UML came from, but if you look at who contributed what, and you can quote me on this, I would say, and by the way, if these numbers don't add up to 100%, that's because there was a lot of overlap between these things. A lot of the work that Jim Rumbaugh did matched some of the work that Grady did. So between the two of them, actually, there was quite a close mapping. This had to do with, and I'm not trying to demean it, but it really had to, it was just an add-on. It did not have any impact on, say, things like class modeling and so on. So it wasn't that big a contribution, although they get the three amigos thing. And actually, other people did contribute significantly in some areas. For example, state machines were done by a lot of the iLogix people, and to a certain extent by us at Object Time. So when the OMG came out with a request for proposal for these things, there were 6 initial submissions. Look at the names of these companies. Do you recognize them? Some of them disappeared. It tells you, by the way, that the tools business is not particularly lucrative. But I'd like to actually single out, first of all, Steve Cook, I think, he had a brilliant vision for what these things should be. And it was very much oriented about being precise and so on. So his contribution was enormous. He contributed OCL. I don't know how many people know that. It was actually something he had developed as part of his own company, which he had for a while before he joined IBM. And a subset of that language became OCL, which was actually consolidated by Josh Warmer. But it was Steve Cook's idea, and he also contributed this idea of a family of language, which to us in a very rough form was accepted within UML1. Another person I would like to recognize is Philippe Defray, who is, of course, French, and he worked for Softeam. He still works for Softeam. The idea of profiles as a first-class concept actually came from Philippe. And very much I would like to recognize the ideas of Trygve Renskog, a fellow from Norway, collaborations, role modeling. I don't know how many of you know that Trygve was responsible for the model view controller pattern. He introduced it when he was working in Park Place, the Xerox Park Place. He had a sabbatical there. One of the things that he and I and a number of others fought for was this thing: objects before classes. So just to illustrate what that means, I've reduced it to this kind of apocryphal story. We have a 5-year-old here, and we have a software engineer over there. And they're both asked to draw a diagram of a car. Okay, well, the 5-year-old draws something like this. How many people think this looks like a car? Anybody? Yeah, it looks like a car, right? You can kind of recognize it. Yeah, there's 4 wheels there, there's axles, there's a body. The software engineer will produce something like this. And what really actually, by the way, surprises me is that I find that people on the right-hand side are puzzled. I'm not exaggerating, are puzzled by the left-hand side. They find it unintuitive. What are these things? Because they keep looking for classes. You know, so this is basically based on this instance-oriented thinking. As I said, object-oriented programs are not classes talking to each other. They're objects talking to each other. They happen to be, in some cases, instances of classes. And of course, the relationship between classes, capturing that, the general relationship between classes is an important thing. But to be honest, if I'm writing a program, the important thing is on the left-hand side, not the class-based thing. In fact, there are many languages like Self and a number of languages that don't even have the class concept in them, and yet you can write perfectly good object-oriented programs with these languages. So in my opinion, and this is almost a tragedy as well, there's far too much emphasis on class modeling when we use UML. I would say probably 80% of all models, UML models, have class models in them, and then maybe another 15% also add things like interaction diagrams and maybe state machines, but things like collaboration diagrams, which are really about the left-hand side. Those things are rare. In fact, I spoke with the author of one UML book, with the authors, and they said, and I asked them, why didn't you put collaborations in your book? And they said, we didn't understand them. And collaborations should be as obvious as that thing on the left. There's an extra element to it where you generalize the fact that something is an instance versus whether it's a role, but that's a second-order thing. So if I'm talking about modeling object-oriented programs, collaboration-like things, or structured classes as they're called in UML2, surely should be a first-order thing, and yet they're not. Okay. So here's the secret bit. I promise you the secret history. See, it's not that much of a secret because I suspect a lot of people are aware of it. There were 2 camps. I call one camp the fuzzy wuzzies. The other ones are the pedants. Right? The fuzzy wuzzies thought all about, it's the Martin Fowler school of let me draw. I don't want to be too bound, which is, by the way, a very important, in fact, it is the dominant use of UML, I would say, is the fact that people just sketch. They use whiteboards and maybe some UML tools to get just the idea across, these so-called prescriptive models. Whereas these folks were, always asking the question, well, what does it mean? Right? And sometimes that's a good question to ask, but not always, especially when I'm doing initial thinking. Precision comes at a cost, by the way. Right? Everybody knows that. So these were the three amigos, and they were more in the fuzzy-wuzzy camp. That's what we called them, by the way, in Rational. The Rational bought my company, so I ended up in Rational, and then to my great misfortune, Rational got bought by IBM. So, and then there were all these other people who were actually the precise people. Okay. And some of them are here. I see Tony Clark there. I see Ed Seidowitz there. Steve Miller was there earlier. Bernhard was part of the Precise UML group. There were others. I hope I haven't left anybody out. So these people were interested in the so-called the descriptive or informal models. Very useful category. And in fact, I can tell you all three of these people were very much against the idea of making UML more precise. Maybe I could have added Martin Fowler here. He didn't like the notion that UML had gotten more precise and so on. And these people were the prescriptive formal modeling, and there was this huge gap between them. And that was maybe the tragedy of UML that we've been trying to fix for a while. Just to clarify, descriptive models, prescriptive models. Descriptive models, by the way, are used for a set of purposes that are not necessarily directly related to implementation. So in order to understand, for analysis and just reasoning about things, I don't want to get into too much detail. Please don't bug me with typing my boxes. I'm just trying to get an idea across to myself and possibly to others. And if it turns out to be a bad idea, well, I could throw it away easily, and that's very important. But making these things lightweight is fundamental. You see, once we invest a lot of effort in building a model, we are naturally reluctant to throw it away. And therefore, we start patching it. So, especially in the earliest phases of development, when you're trying to explore the design space, you should have a very lightweight mechanism. And this is why compilers and prototype code are a bad idea. Invariably, you have to put so much effort. You have to put every comma in the right place, every right bracket, left bracket in the right place. And that takes time and effort, and it deflects from your thinking because you're trying to actually look at it in the highest level, but you are forced to look at the levels of stupid syntactical detail, which is not important at that point. So making it lack of precision is actually crucial to the success of lightweight modeling. And they're less constrained as a result, and again, you benefit from the lack of precision. Prescriptive models, on the other hand, are used for implementation blueprints, and in many, actually even industrial cases, they're used for code generation. And for that, you need detailed and precision. So I got 2 minutes. Okay, 13 of 26 slides. Okay, let's, no worries. Who won? The pedants. However, even they have split into two groups. There are the methodologists, and there are the executioners. So these people are not interested in code generation because that comes with a lot of baggage and a lot of precision and all that nonsense. They want precise models that can be analyzed for safety, liveness, and whatever other properties. Over here we have people who are interested in executable models and programmability. And what's happening now in the UML community is a lot of formal, Ed, wait until I get your picture up here. I have to recognize the work of Ed Seidowitz, who is over there taking pictures of himself. He has been an immense contributor to this. In fact, I would say 80% of all of this stuff, FUML, which is the foundationally executable UML, which actually has a formal mathematical definition, which you can't say for Java or C++ or anything. ELF is a surface language for UML action language. We have also been working on precise semantics of composite instructions, and now we're involved in this horrible effort of trying to define the precise semantics of UML state machines, which is just a nightmare, I can tell you. But Ed and a number of other people from CAA, like Jérémy Tatouguet, are fundamental here. Is programming with UML a good idea? Yes, yes. And the problem, of course, is if you have a precise language, then you get saddled with things like typing, syntax, commas in the right place. Darn it, you missed that comma. You forgot to type this variable. That's not what you want. But I don't see that precision gets in the way of lightweightness, as long as I have what I call the variable strictness slider. And what is the variable strictness slider? It gets around the compiler tyranny. Let's get rid of compiler tyranny. Compilers are unforgiving. They're fascists, right? A compiler will say, you are missing a comma. There's no way I'm going to produce anything until you fix that comma. And that is not the way we do lightweight modeling. And again, the point is, what this variable strictness slider means is that I should have the ability to enforce the formality more and more based on what my needs are at the moment. And then I can perhaps proceed with that wonderful idea that I can start off with a very high-level model, and then just by refining it without changing the language, without changing the tools, without changing the expertise, I can go into an implementation. And that, of course, means that a lot of the design ideas will get preserved. I have a lot to say on that, but I think I'll skip that because I'm running out of time and see where I can get. Now, this is a Mac. Where's a page down here? Okay. I used to be a Mac person in the 90s, and then I gave up. Yeah, I'm okay. Okay, let me reach to talk about the conclusions here. You see, I'm out of phase with everything, right? So when I abandoned the Mac, then it became popular, and I switched to UML. So in a way, UML has succeeded. It'll be around. I think it's like the Fortran of the modeling language generation. It's just too much invested in it I can tell you, I teach in a number of universities. I visit many universities, and the fact is it's taught everywhere. It's taught badly everywhere, by the way. They teach class diagrams, and a lot of these people don't understand that class diagrams talk about collections rather than instances, so the teachers are confused. It's like bad teaching in math. You know, a lot of people learn to hate math because the teachers don't teach them properly, because the teachers don't understand it. It's used primarily as a sketching facility. It was designed at a time when we didn't have a good theory of modeling language design. That's emerging nowadays. We do have a better theory of modeling language design, or a start of a theory of modeling language. It's still not as if like it was in the, you know, if you want to do programming language, go and read a programming language book. And you'll learn how to do it, and that's enough. There's no such thing as yet in modeling languages. But a large number of, this is the thing that actually supports it in many ways. And of course, the research community here supports it to a great extent. And there's no doubt we can do better now. We can produce these, I believe, full cycle languages with also extensible base languages. If we take some of the good principles that are behind UML, we could do a lot better, and we could actually realize the true model-based, or MDA vision, if you like. Since this talk was a bunch of opinions, I take no responsibility for any of the claims made, so I will not take any questions.
Thank you very much. Maybe a couple of questions. I'll start to the room. No, it's not like you have any choice here. don't you think that those different perspectives on the UML are simply complementary, that there is no reason to believe that they are not compatible, that they are needed at a different time in the life cycle, and they are needed in different contexts and for different applications?
Well, I think you definitely, you need sketching. In fact, like you say, that has been the most successful thing, right? The only thing that I disagree with, you don't have to have loose concepts to do sketching. You can use the precise concepts in a sketchy way. By the way, we tried to do that with the UML meta model. I don't know how many people know the fact that, for example, a typed element in UML can have 0 types. And that's the reason we do that, is so that we can actually loosen it so that, it'll still be a valid model, even though I haven't defined a type on it, right? But I think that's the wrong way about it. I like my variability slider idea, but that's not how UML is structured. So I should have the ability to classify my precision into loose, all the way through to tight, depending on what phase I'm in. So to answer your question, I think, yes, definitely you need both, and at different times, but the ability to do it in some kind of seamless way, I still believe, and I've seen it work. I've seen it work not with UML, with other cases. It is a wonderful idea, and it helps preserve design intent. Although, of course, when you get down to an implementation model, what you find is that the models themselves are not actually understandable. They're not good for communication. That's what the problem with prescription models. But this is where the wonderful world of model transforms can help us, and we can hopefully extract a descriptive model out of a prescriptive one.
Well, I was told by the boss that we don't have more time for questions, so thank you very much again.
Thank you.
We will hand out the actual award tonight at the banquet.
So this concludes the award session.